Hello, this is Sean Barrow from Lattix. Thank you for attending our webinar today. As many of you know, I'm the Director of Sales and Marketing here at Lattix. And today I'm very excited because I'd like to introduce our new partner, Verifa, to you. They've been doing some very interesting things in terms of Lattix and DevOps. They have a real focus on software architecture in a kind of continuous integration environment to improve software testing, builds, and productivities. Today, Frank Waldman and Neil Langmead from Verifa will be walking you through this approach. So during the webinar, if you have any questions, feel free to put them into the chat window and or actually the question window, and we'll save some time at the end to answer those questions. So with that, I think now I'll hand things over to Frank to introduce you to Verifa.
Hello, everyone. You may remember me, some of you, from my time with Lattix as a co-founder. I'm here today with Neil Langmead, who's my co-founder in Verifa. A little bit about Verifa. We are a relatively new company. We've been engaged in projects in China and in the US and now in Europe as well. And so our focus and vision is on building better software. We have a very interesting and unique version of DevOps that we're going to show you today. And basically, we're helping companies innovate and automate a lot of the common tasks around building software with high quality. So you all are familiar probably with this graphic, which shows the continuous loop of all the activities required to develop and build software. And it's indicative of all of these DevOps pipelines that contain a high level of automation. We're focused on removing the barriers between dev and ops. And because companies have distributed software development teams, DevOps is really the scalable way to implement the processes that you need. And it's not just processes. It's actually everything involved in quality testing, the people, tooling, all the activities that go around an integrated DevOps. So for us, though, we have a fairly unique approach to it, we think. We have an architecture focus, and that's why we're so excited about our partnership with Lattix. We see opportunities for using Lattix in many of the steps involved in a DevOps pipeline. So we're going to focus on that today. Just to elaborate for you, though, you all are familiar with using Lattix in design. In fact, many of you are architects, and you're well aware of the power of Lattix to help you understand and define your architecture. And some of you have implemented the dependency rules that help you enforce that architecture while people are coding. At Verifa, we've taken it a little further and shifted this to the desktop so that developers, as they are creating dependencies, have the ability to see a bad dependency and better understand it as they code. So they're architecture aware. And then for building the software, we found a great opportunity to help people modularize the system, break those dependencies which complicate the building process. And we call that the smart build. And then finally, in testing, I know many companies have invested a lot in unit testing and integration testing, and it's always a real pain to do it. It's often difficult to know even where to start testing. And we've come up with some really interesting ways to use the architecture to help inform the best way to prioritize that testing, and in many cases to even optimize it. Of course, why do we do all this? You know, we're trying to build value. So architecture compliance is only valuable if you're able to build stuff better, faster, and cheaper. So that's our focus. Obviously, it's an investment you make in a pipeline. And so you have to show that return on investment, and we'll touch on that today. And then finally, there's no time like the present, right? You know, you don't have to boil the ocean all at once. You know, you can take a series of steps to build out this capability. And that's what we've been doing at Verifa to help companies do that. We're a services company. We have expertise in all of the tools necessary to achieve this kind of a pipeline. And with that, I'll turn it over to Neil.
Good day, everyone. As Frank and Sean have already said, we're excited to show Lattix in a DevOps environment and to show some real-world experience of applying this in a pipeline setting. So without further ado, I'm going to jump straight into Lattix Architect firstly, and just give a very short refresher on the information that's contained in a DSM, a dependency structure matrix, and then how that data can be used in a pipeline to drive better results, to drive faster delivery in the software, to create these automated delivery pipelines for our software, and to ultimately achieve shorter delivery and release cycles, which is one of the purposes of DevOps. So by way of reminder for many of you, this is a dependency structure matrix in Lattix. I've loaded the visualization of an open source component called ISO AGlib. ISO AGlib is an open source embedded system, and there is online there is a good description of the system architecture for ISO AGlib. And inside this component, you can see clearly there is a design intent and layering intent that's communicated by the system architects. And for example, if I hover over the available architecture description, you'll see terminology such as optionally to be included modules, and some modules are mandatory parts of the ISO AGlib library. So there's clear architectural intent communicated in these diagrams and pictures. But how does the real architecture of the system look? If a module should be optional, then there shouldn't be any dependencies to that module, because otherwise it would be mandated and required to be part of the system. And you can see clearly in the communication layer there are many optional modules if I look horizontally across the architecture. So with the original plan in mind, we see if we load up the architecture of the system that there are discrepancies or differences between the intention of the architect and the implementation of this software. For example, you can see clearly that there are couplings between the components of COM, which were, as you remember, optional modules. So we see that in the DSM by, if I can remind you, the dependencies or the numbers in the columns are using and the numbers in the rows are used by. So the way we read this is that the import component here inside COM is using can 10 times, it's using singleton.h twice, and alternatively, if we read across the diagonal, we'll see that network management part 5 is used by component 2, which is the task controller client, 37 times. And what we've been able to do up until now, as you're very familiar with this, is to put these rules and design tenants inside Lattix DSM. And so clearly you can see there are rule violations here because the actual architecture doesn't match the intention of the architecture, and that's clearly demonstrated. But our thinking at Verifa was, well, how wonderful would it be if this information wasn't just served up at the system level, but it was actually communicated earlier in the lifecycle inside a pipeline and communicated and pushed to the developers so that we get this information of a rule violation much earlier in the process. And that's where we came to, in our research and development, to the idea of TX, whereby we define certain time points in the software development lifecycle. We say T0 is the earliest point in the lifecycle where we can remediate an error, such as an architectural rule violation. and that's typically inside developer desktops. T1 would be at the integration phase when we're integrating certain components, and then we can define T2 and T3 as higher level phases at different branches, for example, at the integration branch or quality branch as we go further towards the delivery of the software. So this is our DSM, and we want to put this into a DevOps pipeline to enable the automated enforcement of these rules at these various time points. Now, traditionally also with tools like Lattix, they've tended to be installed on single developer desktops or maybe on a client-server architecture from a USB stick, that kind of thing. In DevOps, we have the wonderful concept of infrastructure as code. We can provision things like tool installations as code, and as part of that, we can abstract the installation away from development and from the burdensome configuration of tooling and the running of services and all the maintenance effort that's typically associated with configuring and running and maintaining a tool. So what we have done is we've converted the tools inside a DevOps pipeline and provisioned everything as infrastructure as code. Just by way of reminder, what should a DevOps pipeline, what should the attributes of a DevOps pipeline be? Well, firstly, a pipeline should be consistent. It should be trustworthy. It should be resilient. So if a pipeline goes down, we should be able to self-heal, and the pipeline should be able to restore itself when things go wrong, and it should be able to do so quickly and automatically. We've all been in a situation where a local machine crashes and it takes so long to reboot or so long to reinstall programs. And if your laptop's ever crashed, you'll know that pain particularly well. And it's true also in a traditional setting. If you have tools on a server and the servers go down, they cause many man hours of downtime. So resiliency is a key thing. Ability to self-heal when things go wrong, provide a quick turnaround, and maximize the uptime. The DevOps pipeline should also be consistent. It should be consistently deterministic. It should be reproducible, and it should be trustable. And that's one of the benefits that code gives us. If we implement a DevOps pipeline as code, then rerunning that code in a consistent environment will deliver the same results each time. And the thirdly, so there's consistency, there's resiliency. The third point would be scalability. You're probably in a situation that we're encountering many times is that code complexity is increasing at an exponential and often dramatic rate. We're seeing software complexity going up and up and up. And as that goes on, testability of the system gets more difficult because the lines of code is getting higher, the numbers of paths through the software are getting higher. Many of our customers are working in a functional safety environment to work to software standards such as DO 178B and the FDA, where you have to prove 100% code coverage or 100% unit test compliance. So the question is, how can we test in these ever more complex situations? And again, we were able to see that the DSM from Lattix was able to provide use cases and data that helped our testing workflow. So for example, in this DSM, you see which components are linearly independent from each other. What we can then do is we could abstract or parallelize the testing and the building of these components independently. So for example, task controller clients, file server clients, they're independent of each other. We could give the testing of these two components to two different teams, knowing that they wouldn't need to interact with each other. So we have this data that we can use to help with test prioritization. Also, if you're struggling with long build times, we can use this to build in a smarter way. And we have a concept called smart build, whereby from the DSM, from the architecture, we're analyzing which components are linearly independent from each other, and then we're giving this information again as code to the pipeline. The pipeline is then delegating the building of independent components to its build agents, which systems such as Jenkins and Electric Commander, so build infrastructure, CI tools such as these, then delegate the building on these agents automatically, and then we can collate the individually built components on the build agents together to solve the bigger problem and reduce the build time. And we're finding that as the code complexity does indeed increase, if you have 1 million unit test cases, for example, to test 1 million paths, it doesn't make sense to rerun those tests with every code change. And so what we've done at Verify is implement something called change-based testing, whereby we're analyzing, again in the pipeline, which I'll show very shortly, the changes that are committed in the repository, working out the transitive closure of the change on the entire system, and then retesting only those parts which are affected by the change. And you, of course, can do that with any part of Lattix. You can mark any component as changed. You can expand members to examine right down to the member level which components are in the system. And then for any given function in the system, if we mark that as changed, it would compute the complete effect of that change on the entire system. So this is another source of data that we're giving to the pipeline. Further, I've alluded to the fact that we can help with integration testing, unit testing, and code coverage. We have automated scripting capabilities to pass this data to other tools, such as testing tools such as Cantata, which operate at the unit test and the integration level. And further, we can also load up test data from the test runs to see where we have sufficient coverage, where we have insufficient coverage, where we have test passes and test failures. So with that in mind, let me show you some of those, the implementation of this inside the pipeline. So firstly, let me give you the standard view of ISO AGLib, the project we've just looked at in Lattix. What you're seeing here is our implementation of the pipeline in Jenkins. And as I say, we've provisioned everything as code. So this whole infrastructure behind this Jenkins.demo.verify.io infrastructure is based on Kubernetes, a Kubernetes cluster to manage those build agents that I talked about. And Jenkins is the master that's orchestrating the DevOps environment. And we're also using Docker. So all of the tools that you'll see, all the stages that I'm going to show in the pipeline are implemented in separate Docker containers. Now, the benefit of that is that we have this scalability. We have the self-healing ability. If any part of the system goes down, the agents can refire up automatically, and that's orchestrated, controlled from this Kubernetes. So here's an example of the Kubernetes code that we've written. So we've provisioned all of this as code. And you can see that it's a scripted code, it's a YAML file that we then explain the worker constructions, we have to explain the tooling constructions, and the Docker instances are fired off from this Kubernetes pod YAML file. The actual pipeline, if I click on the pipeline here and show you these different stages, what you're seeing here is start to finish a software delivery pipeline. So if you're working in an environment where software quality matters, then you need to take your code through various stages. You need to build the code, obviously. And let me fire a question to you. Do you trust your build? If you're having build issues, for example, 1 minute your build is reliable, the next minute you do a debug build and it fails, or you maybe need to rerun the build command twice or 3 times before it actually delivers the executables that you're trying to build. If you have a situation where your build is maybe slightly untrustworthy, then this is the answer. This is one of the ways that we can help you, is to abstract the build and create a reliable build infrastructure that works every time. Also, as I say, if you're struggling with long builds, then this architectural-driven approach to do the smart build will definitely help you to build those components much faster. And if we can increase the speed of the build, we decrease our release cycle, the time it takes to release our software. So let me fire another question to you. What is the cost of a null release to you? So a null release is if you change 1 line of code, how long at the moment does it take you to up-issue your version? What kind of process do you need to take your modified 1 line of code through before you can say that it's okay. Now, in Verifier terms, we talk about isolate, verify, merge. We talk about taking a code change, isolating it away from the main line, and then verifying this locally, verifying the changes locally before committing to the main line. So let me just show you a picture of that. The reason we do that is hopefully clear, but in a traditional context where people are maybe committing code consistently to a mainline branch, everybody's committing to the same place on that main line. And just think, if my code contains a bug, then as soon as I've committed it to the traditional development branch, then it's visible to every other developer who's also writing and committing to that branch. So that means if I consider this in medical terms, I've contaminated or infected the main branch with my bug. And we all know, in English, a bug is an insect, and insects grow, and sometimes bugs also have a life cycle, right? Like an insect, it grows, and we need to decide whether we're going to eliminate this bug now or defer it. And often when we defer it, it gets bigger. And so the impact of a bug increases the earlier it's checked into the common code base and the longer it stays there. So that's a traditional way of working. But if we isolate through pipelines and give the developers the ability to test earlier and test often in isolation from the main line, then what they can do is effectively spell check their code. They can check for bad dependencies. So for example, in the C world, if source is talking to library, that would be a good relationship, a good architectural use. But if I'm working in library and suddenly I create a dependency to source, then that would be considered to be a bad dependency that I've created and violating the architecture. But that could be detected at the build time with this system by giving the developers and empowering the developers to test earlier and often with this pipeline. So when we do that, what happens is the release cycle is much shorter. And this is our experience at our leading customer. A lot of these ideas came from our work with, firstly, Siemens Corporate Technology in China as a research project that we undertook, and secondly then with Siemens Healthineers in the US, where we developed some of these ideas precisely to decrease the life cycle of a build and to be able to release faster. And so our iterations can increase, and we can build and release much more quickly. So basically, if you consider this infinite loop, we're tightening this loop and making it as tight as possible between code, test, build, release, and deploy. So a visualization of that pipeline. Let me go back to the live view. Is follows here. We would typically perform after the build, which is hopefully now optimal. It's as fast as possible because we've done smart build using the Lattix data. We then pass to the static analysis tools that we're using, and that finds defects such as memory leaks, null pointer dereferences, buffer overflows, all of the things that you normally perform at static code analysis. And then adjacent to that, we would then start the architectural analysis, which can be considered a form of static analysis as well, by implementing these rules and dependency rules and finding violations against those rules. So we've tended to put Lattix in the middle of this pipeline because it speaks both to the left and to the right of these use cases. That is to say that the data that the architectural analysis provides can help with the build through the and assist modularization and assist building faster components. And also, as I said, from the scripting capability, we can serve data to your unit testing tool and integration testing tool. So from the architecture, for example, one thing we did at our largest customer is automatically derive the partitions for integration tests. So many companies that we work with struggle with integration testing. And the reason is there's an infinite number of combinations of modules that can work together. But the architecture and the DSM clearly show which components naturally belong together. The partitioning inside Lattix does that. So for example, you see the files here in the CAN component, you see exactly which elements that are being used by CAN. And so we can automatically construct for example, integration tests using cantata into the cantata framework directly from scripting from the architecture. And when we did this, we found that the integration testing phase was more deterministic, which was one of our requirements of a DevOps pipeline. But not only that, it was also shortened by 3 months on a real embedded project that we applied this methodology to. And that shortening of 3 months was done because the main use cases could be clearly identified from the architecture. So we run the integration test with every change. We can then run an open source scan. We have the technology now to analyze the source code and to, for example, find which open source components you're using in your application. Maybe you're like me as a developer and someone asks you to do something. The first thing we go to is GitHub, and we try to find something similar. So I was asked recently to write a stack. I went to GitHub and found some stack code. 2 minutes later, it's in my code base, but nobody's checked that from a licensing, compliance, or security perspective. And so many organizations now are aware of the risk that open source provides. Again, in the DSM, we can model the dependencies to third parties and clearly see whether there are links to code that we're not expecting. We can also check the APIs. Clearly in the architecture, we see the public APIs going out from our software to the external world and how other components are using those APIs right down to the member level. So we also are able to use this data to look at, for example, attack surfaces in our security policies and to assist with making sure that all our APIs are as they expect them to be. We haven't got any unexpected data exposed. Data that should be private to certain components is not being made visible across the trust boundaries and across the interfaces. And so we can also use the data in that part of the pipeline. So let me go back to the various branches. As I say, we've used Kubernetes, we've used Docker, and all of the tools that we use in the pipeline are now inside Docker containers, and these stages are automated in this way, and we're linking together through this infrastructure as code and data-driven approach. We're passing data from the build to the static code analysis tools, to the architecture, and then right through the entire pipeline. So this demo is freely available for you to have a look at. Let me just explain a little bit more about the backbone of the pipeline. We've covered the reasons why we would want to do this, so testing at T0. Let me just go to this picture here, which explains the backbone, which, as I say, is Kubernetes, Google, inside the Google Cloud, and then running these Docker containers. So the advantage of Docker is that we can abstract the installations completely in a few lines of code, and you saw that in the YAML code. We're able to, with a few lines of code, specify that Lattix should be deployed in a pipeline, in a virtualized environment, and then Docker takes care of the abstraction. So in this case, it sits on a Linux-based cluster. Docker takes care of the main Linux kernel, and then the Docker instance puts Lattix on top of that Linux kernel. And again, the advantage of that is that the developers themselves no longer need to worry about settings for the tool. They no need to worry about the downtime or maintaining the server or maintaining the data that's associated with running these tools. That is totally taken care of. And also, if the system goes down, as I say, it can self-heal automatically by spinning up another instance of the Docker container. So these are some of the advantages on why you would use this kind of system. So let's look at some of the results. You can see, let me just explain from this perspective. Once you've done all these stages, we're connecting on the left-hand side to your source repository. So that may be Git, it may be TFS, it may be Perforce, it may be CVS. You're using some kind of source configuration management system. And I alluded to change-based testing. If you're committing code to your repository, which of course you're doing, what we then want to do is basically validate those changes as quickly as possible. So that if there is anything which has broken any of our rules, it's broken any of our architectural rules, or broken the build, broken the dependency violations, if any aspect of that change has introduced a regression, then we want to be able to validate that or reject it as quickly as possible. So here you see the commit on the left-hand side. We would hook this up to your source repository, and then we can intelligently deduce from the pipeline code that we have, by examining the intended architecture, we can compute the transitive closure of every change that commit's made, and then just rerun those tests which are relevant to those changes. So we were aware that with some companies that we're working with, they were blindly rerunning all the tests whenever a change was made, and sometimes the testing phase was several hours. So as I say, that as the code complexity increases, that's no longer a viable solution. You need smart build, and you need a smart approach to testing that's architecturally driven. So with this pipeline, we have some heuristics, and we have some data from a few customers that we've run this on. The number of broken builds, because we're doing isolate, verify, merge, and giving the developers the ability to find these issues at time zero, for one of our customers reduced by 65%. So if you're struggling with this issue of broken builds, this is a provably demonstrated solution that would help you to combat that build problem. Building with Docker and these containerized tooling is definitely the way to go in terms of reducing infrastructure and maintenance of your tooling. So if you have a suite of tools that you're using to show compliance, to show testing, to show static analysis results, then abstracting that into and virtualizing into Docker would be an efficiency improvement for you. But this is the way we do DevOps. It's DevOps with putting the capital Q back into quality. It's a quality-driven DevOps pipeline that we're offering here, where we're not just focused on the build, but we're delivering a whole software delivery pipeline that automates as many of these stages as possible. So the schematic overview is shown in this picture. We go from code to build to QA to testing and release, and traditionally QA has performed this function here: static code analysis, architecture, unit testing, and open source analysis. What we are doing is linking this up, and DevOps, of course, is the breaking down of development with operations. It's the unifying of teams. It's the creation of cross-functional teams where your architect would work with your developers, who would work with the testers, in order to achieve the desired outcome and the release of faster software. And then T0, static code analysis and unit testing inside the developers' IDEs, but running this pipeline locally. So that's the overview. This is the infrastructure that lies behind all of this. And if I scroll back to some of the visualizations that we have the ability to, of course, when you're doing everything in code, you can send the data to our servers. So, for example, this is Lattix Web running on top of this Kubernetes cluster, on top of and inside the Google Cloud. Here we have published the DSM, in this case for ISO AGLib in Lattix Web, and we can interact with this in a similar way to the way the developer would, or the architect would interact with Lattix with a desktop. And this shows, if I just move this, okay, you can click on, sorry, just sorting myself up. You click on any dependency and see the use, the usage of that, and interact with the model in this way. Also see the cycles that are contained in this project. So this is a form of technical debt. We have all the data served, and because we're continuous, we're also able to examine the trend of the architecture as we go forward. So have we got more stability in this build compared to last build? What's our cyclicality looking like? What's our complexity looking like? And we can make sure that we're trending in the right direction in a continuous way. You can do all that with SonarQube as well. So we can publish all the results from the static analysis, from dynamic testing, from architectural analysis directly into SonarQube, where you get a holistic view both of the technical debt and of the remediation effort that you need to perform to achieve the quality goals. One thing that we heard recently from a customer that we worked with to deploy this pipeline was that people stopped talking about technical debt that was on the project. And obviously technical debt is quite a negative term. Like any debt, like financial debt, it needs to be repaid. Everybody understands that we can't keep deferring problems post-release. And so people understand that like financial debt, it needs to be paid back, and also that the cost of paying back increases the longer the debt is outstanding. And it's exactly the same with the technical debt, and it's especially true of architectural debt. Because if we incur dependency violations, or we introduce cyclicality, we introduce dependencies that break our intended architecture, that creates a maintenance nightmare and spaghetti code. So we have found, and this is a wonderful quote from one of our customers, is that the whole discussion moved away from the terrible cost of having to pay technical debt, and also the cost to morale when projects get into these situations, to the creation of technical wealth. And so what we can do using this approach is basically create reusable libraries. Our software assets become our asset base, that we can now talk about software and technical wealth, and the creation of technical wealth by creation of reusable software assets, such as libraries that are well defined, that have great dependencies, that have great APIs and secure APIs, that can be reused time and time and time and time again to great economic value for your projects and for your companies. So many companies that we're working with have found that this is especially valuable for platform development. So our biggest customer is actually using this entire system to develop a platform that's going into many different medical devices. And again, you know, the cost of a defect is extremely high, because if a defect comes into platform code and that platform code gets propagated into many different devices, then you're looking at an exponential cost of a defect. And so with this system, we're able to validate changes in the platform well before deployment, and to do pre-flight builds, pre-flight tests in the pipeline. So yeah, there's a very positive quote that we got is you're helping us to create technical wealth, rather than in the past our focus has been on technical debt. So just to finish off with some additional screenshots from a real project that we were working on, we found when we deployed the pipeline, code coverage increased because the components were easier to test. And so here's a visualization of some source files that were tested. The automated test case generation was a lot faster, because the dependencies were well defined and well managed. Code coverage increased, and we were able to drive coverage metrics much higher on this project than had ever increased before, and we were able to measure that and put that as a quality gate in the pipeline, and to trend the entire information. So this is a just to kind of bring our discussion to a closure, just to remind everyone why we're doing DevOps pipelines. We want scalability, so that as complexity increases, the number of agents can scale seamlessly, and we can cope with increased loads going forward on our build agents, on our build server. We can accommodate the increasing demands of the customers as they require many more builds and maybe multiple build configurations. So all of that complexity can be managed in code. We want to automate the analysis of the software for the earlier detection of bugs at time 0, so at Tx, where x equals 0. We want to automate the architectural compliance at T0 and enable architectural compliance inside developer desktops, IDEs, such as Eclipse, VI, Emacs, so that we can detect rule violations much earlier. And we want to feed data to the left and to the right of the pipeline to improve our build time, to reduce the cost of the null release, so up-issuing our software after any change, and to measure that. And once we've optimized each stage of the pipeline, then of course we've solved the bigger problem of the entire stage and how long that takes to run and to release our software. So just bringing this to a conclusion, the infrastructure that we have is reusable. A lot of it is open source, but it's being industrialized. So it works in industry, iDevOps, what is commonly called iDevOps or Industry DevOps 4.0. That means it's hardened and robust enough to be able to use in production environments. It's the backbone for a production environment that delivers real software assets on critical projects, and kind of we commend it on that basis. So from a certification perspective, I know there's many companies on this webinar that deal with functional safety and standards such as DO 178B and ISO 26262 or the 62304 standard for medical. This process has been through audit, and it's certifiable in that sense. It's actually solves many of the compliance problems that software development to these standards has because of the automation that we have for architecture, for analysis, and for the build. So with this platform, it's easy to produce repeatable builds and to shorten that delivery cycle and to get the software shipped faster than ever before, which is obviously our goal as software engineers. It's our goal as DevOps engineers, and it's ultimately the goal of our software organizations to be able to deliver this software as quickly as possible. So with that, I will bring this short demonstration to a close. Of course, if there are any questions, now would be a great time to ask those. And thank you for your attention and for your interest.
Yeah, thanks, Neil. And it looks like we do have a couple questions in the queue. So let me just start from the top, and I'll paraphrase these. But so the first question is what is a good place to start with introducing this sort of DevOps architecture concept into my company?
So a great place to start is we as Verifa offer workshops and guided evaluations to take people through the steps of DevOps, to basically start with an analysis of where you are as a company at the moment. So maybe some of these elements are part of your system already. Maybe you have some of the tooling that we've referenced. Maybe you have some infrastructure or something like Jenkins. We want to start where you are, and then we would perform typically a gap analysis and discuss with you what was missing. We can show you the optimal scenario that we see, that we've developed as we've shown today, and then define a vision towards that. And what we tend to do is, DevOps is a journey. It's a cultural change sometimes for organizations. It's a journey that can take a long time. So for some of our projects, we are 3 years into a 1-year project in one case. And that's simply because we start automating, and then people look and say, this is great, what else can we automate? And we throw a different task into the pipeline. And so with all of these pipelines, because it's code, you can code them in any way you like. So for example, we just started to automate functional tests and smoke tests for one of our customers, which is towards the right-hand side of the pipeline. So to answer the question where to begin, usually some kind of an audit, we would come in and we would have a look at what you have at the moment, and then do the gap analysis, and then discuss with you and see whether you want to move towards this kind of vision. And also a frank question is, where's the current pain in the software at the moment? What's the bottleneck that you're experiencing? Is it with the build? Is it with the test? Is it with your retesting effort? One customer we're working with has version proliferation, for example. They have multiple versions of the same library all over the system. And so this was causing, unbeknowingly, a lot of pain and a lot of issues. So we were able to capture that and put that into our Artifactory-based system with JFrog. So one of the things we have here is proper artifact management as well, where every dependency is captured and served from Artifactory as code. So I hope that answers the question.
Yeah. And feel free to type questions in as we go along here. So I'll just take the next question. what groups, or I guess, what do I need to do to get buy-in from to get something like this started? Which groups should be involved?
So DevOps is about breaking down silos and breaking down barriers between development and ops. We've actually found that it breaks down, if it's implemented properly, it breaks down many more barriers than that, and it creates cross-functional teams in many cases, where there's a fluidity of data exchange, information exchange between architects, between developers, between quality, QA are coming in because they're seeing that they can automate many of their manually driven tests and put those into a pipeline. So typically we'd bring together as many stakeholders in the software as possible. That's of course software management, the people in charge of the build, the people in charge of the release of the software, plus the QA, the developers and testers. We found that all of those people, DevOps touches those needs, as Frank's slide right at the beginning showed. Dev, test, design, and the delivery and the build and the release. So we would typically work with a small group of stakeholders with those concerns, and then bring those together to discuss how we can implement this pipeline and improve problems that are interdisciplinary in nature, actually. So the test team has certain concerns, but the dev team has different concerns. Often they're two sides of the same coin and a reflection of the same problem that's been expressed by those different teams. So one of the things I haven't said anything about is analytics. So we have the ability, for example, to analyze the repository and see who is committing most tests, who's committing most source code in the repository, and visualize that. So from that kind of profile analysis, that also helps strategy, because we can see who has a tester mindset and who has a developer mindset. And very often they're different mindsets. So developers tend to be creative, testers destructive. I want to try and break code and prove that my colleague's code has a bug. So that's the typical mindset that I have as a tester. This kind of mindset is clearly visualized in the analytics, and we can use that to construct these interdisciplinary cross-functional teams to great effect, and so typically would invite all stakeholders who are interested in the software development process to take part.
I guess the next question, which dovetails into your analytics discussion, what sort of working with her?
Very confident on build improvement when we've applied Smart Build and the number of customers who have this problem is increasing. It seems we're talking more and more about the builds than ever before. And it's not just build speed, it's build reliability. And so people are encountering these kind of problems where they have to run the make command twice because the make system or the build system doesn't understand that component A needs to be built before component B. Well, we solve that kind of problem. And obviously with the virtualization of the environment, we're building that consistent environment that's reliable. So increasing build reliability. So we certainly see a massive return on investment there, because faster builds, and we got the build time from 45 minutes down to 6 minutes in one customer, and that totally changed the release cycle, because all the stages post-build were depending on a faster build, and so we're able to deliver massive ROI on that particular project. And certainly from the analytics perspective, because we're connecting to the repository which has the commits, it has the commit logs, which we can also analyze. We can see what the common failures are in those commit logs, like build failures, compile failures. We can adopt even a machine learning approach to those and find, for example, deviances away from the norm. So in one case, we did a statistical analysis of the software, and we found get set should be called with set state. Normally, that was the baseline normal behavior, but then there was a regression away from that behavior that we managed to determine through a kind of machine learning approach, and then visualize that. So there's so many ways that the system benefits the project and produces ROI. Build is the most common, I would say, at the moment, but certainly to the right-hand side of the pipeline, we're finding that the test phase, which traditionally consumes 50% or even more of the entire software development process, especially in functional safety environments, that is being much, much shorter using this approach, because it's data-driven, and people know the integration testing phase is a lot faster with the scripting capability that we've shown.
Okay, great. Thanks, Neil. So next question, have you integrated with PVCS repository?
We do. We do have an integration with PVCS, the source code repository, and that works out of the box, also connecting on the left-hand side to Jenkins, and then doing these staged approaches in the pipeline. So it's a good integration. It's probably not our most common integration, but there are several customers using this tooling with PVCS. Yes.
Okay, excellent. Okay, next question. Can we access different builds from Artifactory and generate Delta reports between those builds through Lattix Web? I guess the build from JFrog Artifactory and generate Delta reports between those builds through Lattix Web.
I believe that functionality can be added. I'm wondering if Jacob is on the line and could take that question, our resident expert on JFrog Artifactory.
I don't know that he is.
Okay, we'll come back to that. I may need to take that question offline, and we will check with our JFrog Artifactory expert. I believe from the question that it can be done. The Delta, so JFrog Artifactory is an artifact management system. It produces, for example, automatically the bill of materials, the BOM. It shows exactly what the constituent parts in any release are. And you can do deltas between the bill of materials between two different releases. Mapping that data into Lattix is certainly possible. I would need to get back to you on how that works in practice and speak with Jacob and Niraj, our experts. I'll take that question offline in some more detail.
Okay, so the next question, what is the mechanism to automatically select tests based on the impact of change determined in Lattix?
So change-based testing is one of the key benefits of using this platform. And so if I click back to the ISO AGlib, what you can do, if I run one of our scripts, for example, to create a Cantata integration test, that works by selecting modules inside. So we can do it in two ways. We can either say generate automatically a test for each of these partitions. So Lattix partitions the architecture according to various algorithms. Those algorithms can include provider proximity or names, alphabetical listing. There's various algorithms that group components together. Provider proximity is the one that makes sense, I think, for testing, because it basically groups things to where they're being used and where they're being defined. And from these kind of partitions, we can generate, for example, a Cantata integration test directly from that. The other way would be to manually select in the DSM the modules that you want to pull into a test. And so you would kind of right-click those modules and then go to the script and then generate you could either generate unit tests for each individual component that you've selected in the DSM, or you could create an integration test. And then what that does, in this case, it builds with Cantata. It would instrument all of the files for code coverage. You can then apply auto tests to generate test cases automatically. Sadly, I don't have time to show that, but we can arrange a follow-up with the person who's asked the question. And then auto tests would be applied for the L1 tests, and then you could add your own requirements-based tests to the automatically generated test cases. And in many cases, we generate 100% unit test coverage out of the box. So we're giving developers a massive start on testing. And then coming back into the DSM, you can load data from tools like Cantata back into the DSM to see where you have got coverage and where you are missing coverage. And further to that, you would be able to then assess the impact of a change on the system. So quickly, the way you do that is you mark it as changed. That then creates a tag, and then you can create you would basically do an impact report on that tag, and then that would produce an impact report on the total transitive closure of that change on the system to show you what else you need to retest. But why do that by hand? Because the pipeline can do that automatically. So we could script that entire process for you, and by identifying which components are the most important in the architecture, we can we can do that by looking at the stability and the importance of the module, and we have a script to do that as well, to find the least stable files in the architecture. So
that might be a subject of a future webinar.
Yeah, right. Yeah. Look, it sounds like that we could actually go further into that. So, okay. I think with that, that's all the questions we had today. Thank you very much for everyone who attended, and we did record this session, so we will be sending out the recording after this. But if you have any questions, just let us know, and or want to get further delve into this any further, just let us know. But thank you.